Hello, everybody. I actually have sky envy because my astronomy club, the Royal Astronomical Society of Canada, owns some property near Laurie Forest and has an observatory up that way. And some of you may have visited the Carr Observatory. And so I know that you've got beautiful skies, and I've not been able to get up to enjoy them for a while. But I'm going to share with you some things for you to look at. And I'm going to I'm going to divide it up. So I'm going to point out a number of things that you can enjoy and appreciate just with your unaided eyes. So just step outside on a clear evening and maybe notice some things that you've never noticed before. And then remind you of some favorites as well. And then if you've got binoculars at hand, then I'll point out some things that you can hunt down with your binoculars and appreciate with them. And then finally, if anyone has telescopes, really of any size, then I'll point out a few things that that people can check out with their telescopes. Now, knowing that more people have unaided eyes than telescopes, then I'm going to sort of put more emphasis on the first part of the first tour than the latter part of the tour. And then I'm going to preview you some of the fun things to put on your calendar to keep an eye out for through the coming year, some of the events that will come through the year, and then open up for questions. So I'll leave plenty of time for questions because I could go on and on and on. I'm just not going to do that. I'd rather pique your interest and then have you perhaps ask me a few things that I can show. So I'm going to just share my screen here, and I'm using a program called Stellarium. And it's a great program. Just let me get this into full screen and share my screen here. So Stellarium is a wonderful program that's free, and it runs on Windows computers, Apple computers. You can get it for your phone or your tablet. I think it costs a little bit for your phone or your tablet, but basically you can run it for free on your computer. And when you do that, you just tell it, it figures out where you are, or you can actually specify that if you wish. And then it'll show you the sky above your heads at any time or date. And you can stick with tonight, or you can go far into the future or review in the past. And I've got mine set for Clarksburg, so it should be in the neighborhood where you are. Really, when you're using these programs within 100 miles or 100 kilometers or so, it's good enough. So you don't have to worry about getting the exact latitude, longitude of your site. The only time that really makes a difference is if you're trying to track down the International Space Station. So it's the timing of the space station varies with your location. So it might be a little bit different from somebody in Clarksburg than somebody in, Toronto, that kind of thing. So first off, I'm going to start off by mentioning that, astronomers tend to be moon averse because the moon tends to brighten up the sky and hide a number of the fantastic dimmer objects that we like to enjoy. But, lots of people really appreciate looking at the moon. And if you're wanting to enjoy the moon, it happens for the 2-week period after new moon every lunar month. And if you want to make a note, that next best moon viewing period, when it's in the evening sky after dinner, will be running from February 2 to 15th, right around in there. So that's a night or two after the new moon, when it's sitting low as a thin crescent over the horizon, all the way to when it waxes to its full moon phase about 2 weeks later. Actually, the full moon is not the greatest time to look at the moon in binoculars or a telescope, because the sun arriving at the moon is all from directly overhead, and there are no shadows cast. So there's a little bit less drama on a full moon than there is on a partially illuminated moon. So those are the periods where you can make a note for that. And that'll be obvious, because if you stick your nose out the window, you'll be able to see the moon when it's up in the sky, and remember to get out there and take a look. But if you're interested in the dark sky, when all the stars are glistening, and the deep sky objects like galaxies and clusters and nebulas are better seen in the Milky Way, that's when the moon is basically between its third quarter and new period. So we're in the third quarter period right now. So today is the moon's third quarter, which means it rises at midnight and then lingers around into the morning daytime sky. So you're going to likely see the moon half illuminated on its right-hand side in the daytime morning sky this week. And every day it'll wane a little bit sorry, on its left-hand side. It'll wane a little bit less and less and less through the week, and eventually it'll reach a new moon next weekend. So we're talking about moonless period between around now to February 3rd. And then a month from now, that'll be February 23rd to March 5th. Now, so that's the moon covered. And I can zoom in and show you the moon if anybody has any particular interest in doing that, if we have time at the end. But right now I want to mention the bright planets. So we've been very lucky for the past most of this year. We've had gorgeous Venus gleaming in the western sky after sunset for most of this year. But as you might notice from this view, and this is again the view this evening around 6 p.m., there's no Venus to be seen. So Venus has reached its peak distance from the sun, and it's already on its way back to conjunction with the sun, and it actually is setting. I'm just going to bring up my little time machine here, and I can just advance the hours and minutes and seconds a little bit. So you can see that the bright horizon, post-sunset horizon, is here in the west-southwest. And there's the sun. And if I actually hide the daylight, you'll see that there's Saturn here, and Venus is down below. So it's actually already joined the morning sky. So we can look at the morning sky here in a little bit. So for now, what we're left with is Jupiter. And Jupiter is a terrific thing to look at with binoculars and telescopes. If you've got binoculars, what you can look for are the 4 Galilean moons. And those are the moons that Galileo first noted back in 1610 when he thought to point a spyglass towards the heavens. And by observing Jupiter over a number of clear evenings, he deduced eventually that these little stars, as he saw them, were actually in orbit around Jupiter, and that they would actually move around from night to night. And the 4 moons are Io, Europa, Ganymede, and Callisto. Here's Callisto out of the screen here, in order of their distance from Jupiter. And the farther from Jupiter they are, the longer they take to orbit. So Io tends to hop back and forth every couple of days, whereas Callisto takes a longer time to do that. So this is tonight's sky. If I pop this into tomorrow night, then you see the arrangement of the moons is different. So that's something you can see in binoculars. So if you've got reasonable binoculars, they don't have to be big. Just point them at Jupiter and look for the little dots in a line on either side of them. That's because Jupiter's axial rotation, or axis of rotation, is very upright. So it actually points directly out of the plane of the solar system. If I put this line on here, let's see if I can bring this up. So this is the plane of the solar system, this ecliptic line, and you can see that the moons are in the same parallel to that line because it's sitting upright as it goes around the sun with its axis pointed up north out of the solar system, and its moons are going around it. So they all remain in that line. The planets that have axial tilts, like the Earth does, Earth's tilt is 23.5 degrees, and Jupiter and Saturn, which has a similar tilt of about 24 degrees, its moons tend to array themselves above and below and to either side of the planet. But Jupiter has this unique pattern where they're in a straight line. So you can do that. You can check out Jupiter any night for the next little while. The bad news is that Jupiter is going to be disappearing soon. So if I advance the dates here from January 25th to the 26th, 7th, 8th, 9th, 10th, you can see that every night it's getting a little bit lower and a little bit deeper into the evening twilight. So we're going to lose Jupiter from view in about 2 weeks, and it'll join the morning sky where all the other planets are partying right now. So as we get deeper into my talk, I'll bring up the morning sky and show you a few events that you can set your alarm for if you want to get up a little bit early and see those. So that's covering the planets. We've actually also got Uranus and Neptune in the sky these days, but they're not that easy to find for beginners. So I'm not going to spend a lot of time on those. But what I will do here is I'm going to bring up the lines that join the constellations up. So let me just reveal the constellations here. So Jupiter is sitting here in Aquarius. And here above it, you can see the great square of Pegasus. I'll come back to that in a second. And if I bring that plane of the solar system, all the planets are always going to be somewhere near the ecliptic line in the sky. And it's always in the southern half of the sky. So if you see a bright dot in the north, it's likely to be the space station or something that's passing that way. But a bright dot in the south half of the sky could very likely be a bright planet. And of course, as I just said, we're not going to have the bright planets in the evening sky for some time. Once we lose Jupiter, we won't get an evening planet until Saturn appears around the end of July. So in July, August, September, we'll get Saturn, Mars, and Jupiter back into the evening sky. But between now and then, we've got to make do with whatever else we have to look for. And that's part of today's talk, is to show you some other things to check out. Anyway, so there's Jupiter. And you can see here's Uranus. And down in here, not far from Jupiter, is dim little Neptune, which is the hardest of all to see because it's not very bright. All right, so let's check out some things that you can look at with your unaided eye. So I'm going to set the time here to 7 p.m. I'm going to take off my ecliptic here just to make things simpler. All right, so here we have the sky at around 7 p.m. I'm facing south. There's this S on the bottom of the screen here. And you've got the green Z in the top here, and that represents the zenith, straight overhead. So you can see that if you've got the horizon to the zenith, or 90 degrees of the sky, and then the sky east and west. And so the first thing I wanted to point out is that when you head out, look at the bright stars and notice that they come in different colors. Well, stars shine with different colors according to their temperatures. So the very hot stars, if you think of a welder, when a welder heats up a piece of metal, at first it's sort of a dull red, and then an orange, and then a yellow. And the hotter it gets, the brighter and bluer and whiter it gets. So the bright blue-white stars are the hottest ones, and the dimmer, cooler stars are the reddish ones, red and orange colored ones. So if you look nearly straight overhead, there's a star up above, almost overhead in the evening now. That's Capella, and Capella is a yellowish G-class star. So we actually give stars spectral classes using the letters in the alphabet. And they're not in the order that you think of. In fact, they actually go from O, B, A, F, G, K, M, because a number of the intermediate letters have been removed over time as scientists have realized that the stars were the same, so they didn't deserve a separate letter. And our sun is a G-type star, and Capella is also a G-type star, which means they shine with a sort of a golden yellow light predominantly in their spectrum. So you'll notice that Capella is a bit yellow in tint. And if you turn around and face north, here's north, Polaris, of course, will be halfway up, or approximately halfway up the sky towards the north. Polaris is not a bright star. It's about number 44 in brightness if you rank them after the sun. And Polaris is also a G-type star. So it has a slight yellowish or golden tint to it as well. So you can compare those two. So there's Capella right overhead. It's the brightest star that'll be just a little bit off the zenith, straight overhead. Then you can look down to the southeast, and depending on the time of the evening, you might see Sirius peeking above the trees or between the trees. If you wait a little bit later, the star Sirius will climb a little bit higher. And Sirius will actually be highest in the sky over the southern horizon at about 10:45. So that's when it reaches its highest. Now, Sirius doesn't climb very high for us in Ontario. And that means that we're viewing it through quite a bit more of Earth's atmosphere. So when you look at an object straight overhead, you're looking through about 100 kilometers of atmosphere. But when you view an object that's near the horizon, we're actually viewing multiple times that thickness of atmosphere. And the more intervening air between you and the object, the more opportunity there is for turbulence to make it twinkle. So the stars near the horizon will always twinkle more than the stars straight overhead. And Sirius is famous for these flashes of light. It's almost like a prism hanging in a sunbeam where you get the red and the green and yellow and blue flashes as you watch Sirius twinkling above the horizon. But basically, Sirius is a hot blue-white star, one of these hot ones, and nearby. And Sirius, of course, is the brightest star in the constellation of Canis Major, the big dog. And I'll come back to that in a bit. And that's why it has the nickname the dog star. And that's why J.K. Rowling used the name Sirius for the character in the books because he had a connection to dogs. If I'm not going to spoil the story for anyone that hasn't read it, but you'll know what I mean if you've read them or seen the movies. The star Procyon, which is not quite as bright, sits a little bit to Sirius's upper left, and it's another one of these hot, bright white stars. And in fact, most of the winter constellation stars that grab your eye are these hot, bright ones. And they're actually burning through their fuel at a more rapid rate, which gives them that intense heat and bright light. And they tend to be a little bit closer to the Earth as well, so it kind of catches your eye. So Sirius and Procyon will be this bright white color. And then you've got Orion, and Orion's got his famous belt. So the belt stars are all about the same. They're kind of the white stars. But if you look at his shoulder Betelgeuse, so Betelgeuse is actually a red giant star, and it has a definite reddish or orangish tint to it because that's actually a bit cooler than the other stars. In contrast, Orion's foot, his western foot, is called the star Rigel, and it actually has another one of these bright blue-white stars. So you can check those out. And let's not forget Taurus, the bull, which is just above Orion. And Taurus has this unique triangular shaped face to it and a bright star in the core of the constellation called Aldebaran. And Aldebaran is also one of these aging orangish, reddish orangish stars. So you can check those out and make those observations yourself just with your unaided eyes. Now, you may have noticed we've got Castor and Pollux, the twins of Gemini, up in the winter sky tonight as well. And this, of course, all this information is valid for the next number of weeks. So don't worry about if it's not clear tonight. You can pick the next clear night. But what I think is neat about Castor and Pollux, they're the famous two twins, Castor and Pollux here, and those names are given to the two bright stars in the constellation. But guess what? They're not identical twins at all. In fact, Castor, the one that's higher, is about half as bright as Pollux. You'll notice that with your unaided eyes. And Castor is kind of a creamy white tint to it, whereas Pollux is much closer to a yellow, a warmer yellow color. And if you do have a telescope, aim it at Castor and zoom in, and you'll notice that it splits into this neat little trio of two stars close together and another one sitting just a little bit off of that. You may pick up sort of these two blobs in your binoculars, but if you've got a small telescope, that's the way to go if you have that opportunity. All right, so I touched upon the square of Pegasus, turning back and looking more towards the western sky. So Pegasus has been a feature of the autumn sky for some time now. We're transitioning truly into the winter sky. So Pegasus is now into the west and descending into the west in evening. But it has what we call an asterism. So there are 88 official constellations in the night sky. And every constellation has its own territory and its own boundary. I can show you the boundaries here. And the boundaries have no overlap and no gaps. So every little spot in the sky, every piece of real estate in the sky belongs to a particular constellation. Now, there are cases where constellations share a star. And that's the case with Pegasus and Andromeda. And so let me just zoom in a little bit here. So 88 constellations, but we also make informal star patterns out of the sky, out of the stars, and we call these asterisms. And an asterism can be a subset of a full constellation. So for example, the Big Dipper is just a part of Ursa Major, 7 stars out of many more. Similarly, the Great Square of Pegasus, and here's Pegasus here. Let me just bring up that picture of him so you can see what I'm talking about. So Pegasus is only a half horse. He's got stars that form his head, stars that form his front legs, but basically his back half is absent. And the big square kind of represents his body or maybe his wings. And the reason that he's only a half horse is because he's actually surrounded by a number of aquatic constellations. You've got Pisces, you've got Cetus, the sea monster, you've got Aquarius, the water bear. And so the classical Arabian astronomers actually envision Pegasus' stars as perhaps the prow of a ship, a carved horse on the front of their ships. And so he only needed to be half a horse. So the asterism is the square inside the constellation. And it kind of looks like a baseball diamond this time of year. So you'll notice that the star Markhab is at the bottom, Alpheratz is at the top. And if I measure this for you, I'll just give you a sense of its size. So if you take your fist and hold it at arm's length and close one of your eyes and hold it up to the sky, everyone's fist covers approximately 10 square degrees up and down, left and right. And so if you want to measure how large things are in the sky, you can use your fist. So in this case, the square Pegasus, edge to edge, would measure 2 fists, 21 degrees. So you could put 2 fists side by side and go from corner to corner that way. And one edge would be about 1.5 fists. So you can use that sort of trick to make sure you're in the right spot and you're seeing the right size of a square. There really isn't another square like it. You really can't miss it. And as I said, the square at the top here, Alpheratz, is actually shared by Pegasus and Andromeda. And this is Princess Andromeda. And all of these are members of the same family from Greek mythology. So there was Andromeda, her parents were Cassiopeia and Cepheus, King Cepheus. They're in the sky here. So here's Queen Cassiopeia, and over here we have King Cepheus. So these are her parents. And then the sea monster is what she was chained to the rocks to be sacrificed to. And then the hero who rescued her is above here, is Perseus. And of course, our friend Pegasus is part of that story as well. So yeah, Alpheratz is actually shared by both constellations. So that's the square of Pegasus. You can look for that. If I swing around and face to the north, you may be wondering where the Big Dipper is these days. So the Big Dipper is actually finished skimming the northern horizon, as it does sort of in December. And now in early evening, it's tilted upright in the northeastern sky, and it's preparing to ascend every night, a little bit every night, through as we get into the spring months. So by the time we get to the summertime, the Dipper will be right over our heads where Perseus is now. So it'll sort of change positions. So that's where you can find the Dipper. And as I said, the Dipper are 7 stars, part of the bigger Ursa Major constellation. A couple of other asterisms you can look for would include, let's see, the winter football. So I pointed out some of these bright stars a little while ago. I pointed out Sirius, and I pointed out Rigel, and I pointed out Aldebaran, and Capella, Castor and Pollux, Procyon, and back to Sirius. And if you actually trace that out, it's a giant ellipse or a 6-sided figure. Some people call this the winter football because it's up in the sky, around Super Bowl time. And the moon will actually pass through the winter football over 2 or 3 nights, once every lunar month or so. So there's the winter football. It actually extends. So here's that zenith mark overhead. So a huge percentage of the southeastern sky extends nearly all the way up from the horizon up to close to the zenith. So that's the winter football asterism. So you can do that with your unaided eyes. And if you go out a little bit later in the evenings, let's just advance this to about 9 o'clock. And this is a case where the asterism is the constellation when you talk about Sirius, talk about Canis Major, the big dog. So really, this constellation of Canis Major truly looks like a wiener dog. So it's got the bright star Sirius where his dog tags would be. You'll notice a little triangle of stars for his head. You'll notice a couple of stars to the right for his feet. And then down here, you can trace his body down, and he's got a little tail that sticks out. Very noticeable when you're paying attention for it. So do make that effort. And not as noticeable, not as bright, but the constellation of Lepus, the rabbit, is right underneath Orion. So the dog is actually Orion's dog, Orion the hunter, and they're chasing the rabbit. So that's another grouping in the sky that's really, really fun. So let me head back to 7 o'clock. So as I said, Sirius is just coming up just come up around 7. So you need to wait a little bit later to get all of the doggy above the horizon. All right. Now, you've got beautiful dark skies where you are. So back to our friend, the square of Pegasus. So while you're in the neighborhood, you want to find the big diamond. And then you want to look for a couple of stars above it. And those stars would be about, let's see, a palm's width. So rather than use your fist, we're going to use your palm. And that's about a palm's width. Look for a pair of stars. And then another palm's width, another pair of stars that are wider apart. And what we're doing is we're doing Andromeda's body upside down. Her head, her shoulders, her waist, and then her feet are up here. And when you get to the first jump, second jump, jump to the right and look for a fuzzy patch in the sky sitting right here. Another trick to doing this is to look for the W of Cassiopeia and take the bottom half, the deeper V, and it'll point like an arrowhead straight towards this object. This object is the great Andromeda galaxy. And this is something you can see with your unaided eyes from the Beaver Valley, no problem at all, on a moonless night especially. Now, it's actually huge in the sky. It's actually 6 full moons wide and 2 full moons across. And so if you get to a pristine dark sky, the darker your sky, the more of it you can see. This is kind of a mirror image or a twin sister to our Milky Way galaxy. It's a spiral galaxy. We're viewing it not edge on, but a little bit tipped up from the edge on. And these 2 extra smudges you see here, one here, those are dwarf galaxies that are kind of gravitationally attached to the Andromeda galaxy. So we call this galaxy Messier 31. It's part of the list of objects that Charles Messier noted way back in the 1600s when he was hunting for comets and kept getting distracted by other fuzzy objects that weren't moving the way comets do. So that's the Andromeda galaxy. Again, you can find that using the B of Cassiopeia or the diamond square of Pegasus. While you're at it, we can head around and look straight up. And now we've got, remember, here's our W of Cassiopeia. Here's Taurus and the bright star. So Orion and Taurus, Orion's over here, and the Cassiopeia is here. We're looking kind of straight up. And you can look for a star, not quite as bright as Capella, but still quite bright. That's called Merfac. And Merfac has a nice little group of stars around it I'll talk about in a second. But if you look between Merfac and the W, you can find another fuzzy patch that you can see with your unaided eyes, and that's called the double cluster. So the winter Milky Way goes right through this patch of the sky, and the double cluster is a pair of star clusters that are inside the Milky Way. I'm going to just bring up a circle that shows you the size of binoculars so you get a sense of what I'm talking about. So that green circle would be the view of your binoculars. So you can see it fills your binoculars quite nicely. So that's called the double cluster. And I'll just put the Andromeda galaxy in the binocular view so you can see. So it takes up quite a bit of your binoculars field of view. All right, so those are things you can do with your naked eyes or with your binoculars. Now, maybe you want to look for stars that vary in brightness. And one of the most easy to spot examples of that is the star Algol. So here's that star Merfac I was just talking about. And remember, Merfac is sitting here between the bright yellow star Capella and the W of Cassiopeia. It's in the neighborhood of the Andromeda galaxy. So Merfac actually has a star kind of below it called Algol. And Algol represents the pulsating eye of the Gorgon Medusa from the Greek myth, where Perseus cut the head off Medusa. And he's flying back to Polydictes, King Polydictes, holding Medusa's head in a bag on his hip. And this group of stars here, you can see Algol, Gorgonea Quarta, Gorgonea Tertia, Gorgonea Secunda. These are the 1, 2, 3, 4 stars making kind of a square representing the head of the Gorgon Medusa. And Algol actually pulses in brightness. So most of the time, Algol is the same brightness as the star Almach, which is nearby in Andromeda. It's Andromeda's foot. But every 20 hours, once every 2 days, 20 hours and 49 minutes, Algol drops in brightness by about half. And that's because Algol has another star orbiting it. And that star is dimmer than the main star. And when that little star's orbit is edge on to us from our vantage point on Earth. And when that dim star passes in front of the bright star, the overall amount of light we see drops by about half. And it takes 10 hours for that star to dim and then brighten again. So it's basically an eclipse. And Algol does this on a clockwork basis every 2 days, 20 hours, 49 minutes. And the next time that's going to be at its minimum is tonight at 5:30 p.m. And you can look up other times when it'll be. So at 5:30 p.m., the sky won't quite be dark yet, but by 6 p.m., it'll be getting dark. So you'll be able to maybe pick out Algol in the sky. And when you're looking at it, you'll notice that it's about as dim as the star Gorgonea Tertia below it. So it's a couple finger widths below it. So it'll drop to dim down to this, be about this dim at 5:30. But then by 10:30 p.m., 5 hours later, it'll return to its regular brightness. And so that's kind of a fun thing that you can do with your unaided eyes. All right. Now, let's say you've got binoculars. There's a few more things that you can check out if you've got binoculars. I pointed out the Galilean moons, the moons of Jupiter, which you need to get out and do right after dinner because it sets early. You can check out the winter Milky Way. I'm just going to brighten up the Milky Way here so you can see where it is. So the Milky Way actually, the part of the Milky Way that we see in the wintertime from Canada extends up from the southeastern horizon right near Sirius, runs up between Orion and Gemini, up through that star Capella and right through Perseus, and it arcs overhead and then descends down in the northwest through King Cepheus and down near the constellation of Cygnus and sort of getting into the summertime part of the Milky Way. But for now, we're really more focused on the winter part of it. So you can check that out with your binoculars. And if you do, you're going to make discoveries of all kinds of clusters and things that are hidden in the winter Milky Way. I can click a button here and reveal symbols where all the little star clusters and things are in the winter Milky Way. And the one that I want you to look out for, one of them, is right here to the left of Orion's belt. So Orion's belt's got those 3 stars equally spaced. And about, let's see if we can measure this, a bit more than about a fist and a half to the left of Orion's belt, kind of below and between Betelgeuse and the belt, there's a smudge in the Milky Way, and it's called the Rosette Nebula. In binoculars, you'll see a grayish smudge, quite large. Remember this green circle is your binoculars, so it's quite a big smudge. And then you can look for our clump of stars in the middle. And what's happening here is that the energy, the radiation from those stars are actually causing the hydrogen gas in the cloud to glow with a pink color. And that cloud is the source of material that's produced those stars in the center. So this is the process of a star cluster forming in part of our Milky Way galaxy. So this is called the Rosette Nebula. So it's really a really spectacular wintertime object. That can be a little bit tricky to find, but I'm giving you some sense of where it is. And you can just basically stumble upon it if you scan with your binoculars and look for that bright patch. But the dead easy one to look for is Orion with your binoculars. So first of all, if you check out the Orion's belt, you can look for a little S of faint stars between the 2 stars on the upper 2 stars of the right-hand stars. There's a big dot, 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 dot S shape. So look for that shape of stars. Then if you focus your binoculars on Orion's sword, you'll see that there's kind of 3 patches of light, and the middle patch of light is kind of hazy, and that's because that's the Orion Nebula. And the Orion Nebula is one of these cases, again, where gas is collapsing and producing new stars, and those stars are producing energy that makes the gas glow. So that's the Orion Nebula. And last but not least in this neighborhood with the binoculars is, don't forget to go on up and look at the V-shaped face of Taurus. So the shape of Taurus here is another set of stars that are in a cluster. They're very nearby the Earth, which is why they're so spread out. But Aldebaran, that orangish star I mentioned, it's not part of the cluster. It's in the foreground. It's only half as far away. And then above the face of Taurus, you'll find the beautiful 7 sisters, the Pleiades. Now, the Pleiades are the daughters of Atlas and Pleione. That's the 2 little stars to the lower left. And all the other stars are the sisters, the sibling sisters. And they're actually sisters of the face of Taurus, which is called the Hyades. And these are also daughters of Atlas as well. He was a busy guy. So those are things that you can check out with your binoculars. Now, I mentioned a couple of things you can look at with your telescope. You can use your telescope on the Andromeda galaxy, but don't crank up the magnification too far because it's quite a big object. You can check out the Orion Nebula with your telescope. And if you do that, you'll find that inside of it, there is a clump of stars in the shape of a trapezoid. And this is called the trapezium cluster. And it's embedded in the center of that big nebula. And you'll see that easily in a telescope. I mentioned the Rosette Nebula. And the last one I'll mention is back to Gemini here a minute. If you can follow the stars that form the body of Castor, the higher of the twins, sort of to the right, you'll find a couple of stars that are kind of prominent up here towards his feet. And right above here, you'll find another really nice cluster called the shoe buckle cluster, which is great to look at. So I'm gonna pause after. I'm just gonna say a couple more things. A couple of things to note for in the sky in the coming year. The morning sky. So let's jump into the morning here. Let's bring it into the 7 o'clock time frame. And I'm going to show you that's where all the planets are. So right now we've got Venus and Mars are sitting here in the morning sky. A month from now, we're going to get other planets joining the party. So Saturn will join the party first. We'll get a couple of cases where on April 5th, let's advance a few more days here into April. So on April 5th, we're going to get, let's bring this down here. Saturn and Mars almost touching. They're going to kiss one another on April 5th with Venus nearby. So that's something you can keep an eye out for. Then about a month later, around April 30th, May 1st, we're going to have Jupiter and Venus do a similar thing where they're almost going to kiss. Then on May 15th, let me just bring this up to May 15th and down a little bit here. We've got a full moon, and that's where we're going to have, and this will be here. Just get rid of my horizon so I can bring this up. So there's the lunar eclipse. So the bite out of the moon will start happening around 10:30 in the evening on May the 15th. And then that'll last. So the eclipse will be a total eclipse for us in Ontario. So this is one of the ones where you get the blood moon, the reddish color of the moon at totality. And that'll last till about after midnight or so. So it'll end right around 2 a.m. So those are a couple of things you can look for. So I'm going to stop now and take some questions.
Well, thank you, Chris. For the folks online, you can either unmute yourself and ask the question directly, or again, just type them out into the chat feature, and I will read them out to Chris as they come in. Being in the position that I am, Chris, I couldn't help but have this image in my head now of our club members tonight shaking their fists at the sky. But you probably get asked that question a lot. If you wanted to get going with a telescope, is there any buying advice you have? How much would one have to spend not to get too much into Chinese knockoffs, but get some half decent piece of equipment?
So
look at him.
I always get asked this, so I thought I'd bring this one up. So this is a nice, capable sort of a starter telescope, not too expensive. It's called the Orion Starblast, and it sits on a tabletop. So it's kind of convenient if you wanted something that's portable and tucks away and doesn't take up a lot of room. It's actually a Newtonian reflector telescope, which means the light comes in the front, bounces off a mirror in the back. It's a 4.5-inch mirror. And then you look down into the tube from the side. It's got a little finder scope that puts a red dot on the sky. And so it's available in Canada from some very nice folks that I deal with quite frequently called the Maison de l'Astronomie in Montreal. I mean, you can order off Amazon, but I like to support the Canadian retailers because they're more likely to give you aftermarket support and advice. So if you're interested in something like that. So that's a great option for people. And if anybody wants to get in touch with me about, more specific buying choices, I can always give people advice as well. I should mention too that I have, if anybody's interested in, let me just get my background here, virtual background. I just want to take my background off. There we go. So I have a book that came out last year, and what did it? It's a guide to seeing the Messier objects with your binoculars, with your telescope. If anybody's interested in these, you can get it on Amazon, but I can also send you one. I can send you a signed one if any.
110 things to see with telescope.
Oh dear. I hope we haven't lost
anybody's interested. So it's kind of a neat book on Messier objects you can see with binoculars.
Wonderful.
All right, more questions?
Yeah, one came in from the chat from Lucie. Could you please repeat the date in May of the full eclipse of the moon?
On May 15th.
All right.
Yeah.
And hand is raised by the line of Marianne and Don Collins-Williams.
Hi, thank you very much. Wonderful talk. You mentioned at the very beginning the observatory up near Lower Lee Forest. Could you give us a little more information on that? Where it is? Is it open to the public, et cetera?
Right. So it is not open to the public. It's privately owned by the Royal Astronomical Society of Canada. But during non-COVID times, we do offer group tours there, but it's not the sort of thing where you can drop in. So if you can become a RASC member and then get full use of the facility if you wanted to. There's a 3-bedroom house there. We sleep overnight. We have lots of, activities and things going on. So yes, not something that you can drop in at, but if you know somebody like Chris Vaughan, then maybe we can set something up.
All right, Christine, unmute yourself and go ahead with your question.
Okay, thanks, Chris. That was a really good presentation, and I have been to the Carr Observatory a few years ago. I guess it was a Royal Astronomy Society presentation.
Yeah.
And it was lovely. It was great evening and wonderful presentation. I just had a question, might be a silly one, but the Southern Cross, we don't see that in this hemisphere, do we? Am I right?
No. You could see it if you visit Florida. So let me just show you how we can find it here. So that's where it is right now. But
Okay.
if I hide the Earth, there it is. So let's see. I think we can get it. When would we see it? Maybe in June. Let's see. GDDD. Yeah, it sort of just barely misses rising for us in the springtime. But if you travel to the southern states or Florida, you can see it from there.
I did see it in Australia a few years ago.
Yeah.
Right. Yeah.
Let me just. So here's Miami. So if you're in Miami, you can see it around 10:30 p.m. in April, the end of April.
Thank you.
No problem. So if anybody's interested in keeping up on what's going on in the sky, I do every Sunday write a blog about what's going on in the sky. It's called Skylights. And I'll just show you the website. And you can either get it and you can either subscribe to the emails, they're free on MailChimp, or you can actually just remember to check out astrogeo.ca/skylights. And so this week's I just wrote on Sunday, and it talks about Jupiter being alone in the sky. And I mentioned when the space station's visible and when there are meteor showers and things like that. So if anybody's curious about that, the link to that would be up here. If you go to the main astrogeo.ca, you'll see that there's a subscribe button, and it's just a MailChimp form to fill out if anybody wants to. So I'm curious, do people have telescopes? Anybody have telescopes?
Not yet.
I may have inspired you.
Sky map.
Yeah.
I have a telescope.
Very good. Well, dust it off.
Yeah,
And they're giving you some homework now.
exactly.
Let me see if I can get you another idea. Get you another idea of a telescope here. Just, if you want to be a little more ambitious than the little tabletop one, you can go for here we go under Skywatcher. You can go for what we call a Dobsonian telescope. And those are the ones that look like cannons. So they stand on the ground, but they work much the same way. And the fatter the tube, the more light it will gather, so the fainter objects you'll be able to detect with them. But they're also good for the moon, they're good for planets, and they're good for just about anything. This one is a 6-inch one. You can also get an 8-inch one. The disadvantage is that they do take up room in the corner or whatever. So you may want to put an Afghan over it or something when you're not using it. Very good. Well, I appreciate your attention today. Thank you so much. I hope I've inspired you to get outside and look up and enjoy the night sky and appreciate the beautiful skies you have in the Beaver Valley.
Chris, may I ask a question? Will you have any access to the James Webb telescope at all? Or what do you think about the James Webb telescope?
Yeah, not personally, but what's exciting about the James Webb telescope is that Canada has contributed one of the main instruments and also one of the facilities that the telescope uses for pointing itself. And so that entitles Canadian astronomers, Canadian researchers to telescope time on the James Webb. Happy to report yesterday or the day before, it successfully entered orbit in the Lagrange 2 point, which means that it's now ready to just be fine-tuned. So they're just basically perfecting the shape of the mirror and getting it fine-tuned to get going. So everything's gone according to plan so far. We're really excited about that.
All
Any
right.
other questions or?
Brenda, over to you.
Yeah, all right. Well, I just want to thank you, Chris, for joining Beaver Valley Probus this afternoon and sharing your knowledge and experience with us. It was very interesting. I'm the one that spoke up and said I have SkyMap, which I just discovered this summer, and I was thrilled. So I'm hoping to do bigger and better things now that you've shared some of your knowledge with us. So thank you for joining us. Appreciate it.
Yeah, my pleasure. Have me back sometime and I'll actually take you on a tour of things to see on the moon. That's always exciting too.
Ooh, that does sound good. All right. Well, good afternoon and thank you.
My pleasure. Thanks, everyone.
Thank you, Chris.